3x squared, yep.
Minus 9.6x.
Yep.
Minus
1.38, right? And then it asks you a bunch of things about that function. So you needed to use your calculator, and specifically you needed to use your calculator because if you tried to do the things it asks you to do by hand, what kinds of numbers would you have to work with? Kind of weird decimals. You could theoretically do it, but is it really something you don't want to do? Yeah, you don't want to have to. Your calculator doesn't care what the numbers look like. It doesn't discriminate against decimals or fractions. It just does it, right? So you needed to do a few things. What was the first thing it asked you to do, Liv?
To shape it.
To what?
To shape it.
What do you mean to shape?
So does that mean
does this go up or down? It goes down because you know the leading coefficient is negative. You're supposed to find the vertex. You're supposed to find the x-intercepts. You're supposed to find the y-intercepts. These are all things you absolutely have to know how to do. So on your calculator, if you were going to graph this, you go to y equals, clear out whatever's there. One common thing is some people don't clear their calculator before they work with it, and then they're surprised when things pop up. Do you see the plot up above? Yeah. We talked about that. If any of those are on, the points are going to come up. So just remember, turn plots off if you don't want to use the dots. Hold on. Negative 3x squared, right? And then what was it? Minus 9.6x. And then what was it? Minus 1.38. And if you just hit graph, you might get lucky and it might look the right way. No, that's not bad, is it? Now, could you get a better window if you wanted to? Yeah, what button do you press to modify the window? Yeah, literally window, right? So let's actually go from, I don't know, negative 3 to 2 or something, right? Oh, that's not what I wanted, right? To 2. If I change that, what's going to happen? Oh, it's going to, a little flatter. That's kind of cool. Oh, maybe I cut it off too much on the left. So instead of negative 3, maybe make it what? Yeah, negative 5. I like negative 5. Yeah, you just want to kind of get a good idea of what it looks like. That's not bad. Now you use your calculator to find the vertex, the x-intercepts, the y-intercepts. Those are the really important points. You can use trace to trace out points, but those points aren't super, it doesn't give you all of them. You need to be able to do that. The only way to get better at it is to practice it. It is not hard once you've done it a few times. It's the same level of difficulty regardless of how hard it was to plug it into your calculator. This algebra tells you it doesn't cross the x-axis in the real numbers, only in the imaginary land. So we don't graph anything in imaginary land, so we don't deal with that right now. But if you want to find the vertex, everybody, second calc, remember? And then what one do you use?
Maximum for this one.
Maximum, because it's facing down. So left bound, you go enter. Right bound, Connor, take a look.
I know how to do it here. I'm just asking Nick if he did something.
Okay, so I go to this right here, press enter. How many people got something like that? Yeah. In your answers, there you go.
Wait, can you use the vars thing?
The vars thing is the thing you only use for the y-intercept. So if you want to use the y-intercept, kids, everybody, take a look. Hands up. Hands up. Hands up. 3, 2, 1. I ask again. I'm going to start putting zeros for class performance every day. So what you can do is you can do vars, y vars, 0. This evaluates the function when x is equal to 0, and you hit enter. You should get negative 2.68 because on our function, what was the number out here? Negative 2.68. When x is 0, what happens to these terms? They go away. When you plug x is 0, they go away. So you automatically know that it's going to be a little bit less. So what did we get there? We got negative 2.68. Excellent. Now, if I were, for example, on this function here, let's just change it a little bit. Instead of minus 2.68 here, let's say I made it like plus what? What should I change it to make it more interesting?
Want to make it bigger?
Let's make it plus 5 like this, right? If I graph this, what's it going to look like? Now what? Don't do this yet, but what does this have? Finding the x-intercepts, what function on the calc do I use here? What function? 0. 0. And what does it ask you for? It's the same thing. You take your cursor and you go to the left of one of the zeros. How many zeros can a function have? How many? A quadratic can have 2, but how many zeros can any function have? If I just say you have a function and tell you nothing about it, you could have as many as you want, right? Functions can go like this.
Wait, so you're going to the left?
The left of one of the zeros, hit enter, and then you go to the right of one of the zeros and hit enter.
0
and then
here is being the x.
Where it crosses the x-axis. Zeros is where it hits the x-axis. That's a really common way to say that. So change it, kids. Do you see that 0 right there? Yes. This is what I'd like you to do. I'm going to take a screenshot of this so you can duplicate the exact same thing. I want you to find the left-hand 0, and the value you need to change the y equals to is, what did we change it to? We changed it to plus 5.6, I think. Ready? It is at 5.6?
Oh, I thought you did just.
No, I just changed it 5.68. So do this, everybody. Change your function to plus 5.68, and then find me the left-hand zero, the zero on the left. Find me the zero. It